You can see that the title for today's class is Biomimicry, Designing Communities Through Observing the Natural World. Um, most of my classes are somewhat related to the issue of community development. But I always think that it's important for the world of development to try to expand our horizons of how we conceive of what good development projects are like, how we can learn from other disciplines, from economics, from ecology, from evolutionary sciences, from biology. And today, I have a friend who works at Arizona State University, and they have a fairly large and impressive biomimicry institute that they have academic programs that are specifically focused on the issue of biomimicry. And he kind of introduced me to this topic about a year and a half ago. And I've participated in some of their courses, and it's really fascinating. I've always had a very profound kind of respect for indigenous communities and rooted agrarian communities, because I see that the lifestyles and the cultures and the local economies that indigenous people develop are very much in tune and in balance and in equilibrium with their territories, their geographies, their environments, right? But this idea of biomimicry kind of gave me another lens to try and understand how exactly indigenous communities, agrarian communities, farming, small scale communities who live generally in rural areas have really used the power of observation of the natural world to slowly over time develop communities and cultures and agricultural patterns and local designing the local economies to really mimic what the natural world is doing. And that's the essence of biomimicry. So today, what I want to start with is a few definitions. If this word mimicry, biomimicry, doesn't really ring a bell, I'm going to try and explain what we mean by that. I'm going to offer some historical examples, both from famous scientists from the past and then also from different indigenous populations around the world. And then I want to look at what's the difference between a superficial biomimicry and a sense of deep or profound or real biomimicry. If you pay attention to the news at all, this idea of biomimicry has actually been making a comeback, but not necessarily in the world of development or in the world of people who work with indigenous populations, but actually in the world of kind of technology titans and multinational corporations have been latching on to this idea of using biomimicry to increase their profits, to improve their innovations, their technologies. And I think there's a fairly large difference between how many modern day technology companies and multinational corporations are using biomimicry and how indigenous communities and place-based communities around the world have always understood biomimicry as an essential part of their lifestyle, of their culture, of their cosmovision, of developing a lifestyle that is in balance and in right relationship to the communities and geographies where they live. So I want to try and differentiate between superficial biomimicry and deep biomimicry. And then lastly, I want to look at the issues of limits in technology, which I think are essential kind of components to how we understand this call towards biomimicry. And then lastly, as a farmer, I always think it important to use examples from my own, I guess you could say, interests, my own passions, my own lifestyle. So how can people who work in agricultural projects in the world of development, or who work with small farmers, or who are small farmers themselves, can understand biomimicry and how we develop agricultural methods? How can we grow our food in a way that mimics how the natural world does this? Okay, so let's start. A few definitions. Biomimicry, this definition here, sorry, is taken from the Biomimicry Institute, which is loosely affiliated, like I said, with ASU, in a university in the state of Arizona. But biomimicry, they say, is a practice that learns from and mimics the strategies used by living organisms to solve challenges comparable to the ones we face as human individuals and human societies, right? The benefit of biomimicry is that nature presents us with many strategies far better at working harmoniously with the rest of nature than many human developed strategies have been over the past. The goal of biomimicry then is to create products, processes, systems. I think we could also add cultures um, that solve our greatest design challenges, or instead of solve, I think I would prefer the word respond to, that respond to the greatest design challenges sustainably and in harmony with all of life on Earth, right? So that's what they mean by biomimicry. For all the challenges that humanity is currently facing, nature has solutions. One of the famous examples of biomimicry, like if you take a course in biomimicry, they're probably going to, or if you Google what is biomimicry, they'll usually give you kind of simple examples of consumer products that have been developed over the years by looking at how the natural world does things. So this is an example of I don't know if you all have ever been walking in the prairie or in the forest, and after taking a hike, you look down at your socks or at your pants, and they're covered with these burrs. So many types of plants have developed over the years seeds that have extremely sticky surfaces, and the idea is that as animals are walking through the forest, these seeds latch on to animal fur or human socks, whatever the case may be. They then travel however long it might be before they eventually fall off, and that allows the seeds to disperse, to conquer new environments, to find spaces where the plant can reproduce. About 50, 60 years ago, scientists were looking at that and they were looking for different ways to kind of create adhesives without the use of high chemical technologies. And they came up with Velcro. So most children, have Velcro shoes before they learn how to tie their shoelaces. Velcro is used in all sorts of different products. And it was specifically developed through scientists and innovators looking at how in this case, burrs, certain seeds in the natural world work. And they took those seeds, they inspected them under a microscope and created a very similar pattern in the case of a specific consumer product, which in this case is Velcro. So that's one example, right? But what we're trying to get at in class today is that biomimicry is not simply about trying to hack nature's processes, trying to take advantage of nature's wisdom to come up with some innovative profit-making technology that can be applied to a consumer product, right? That's usually how it's seen today in many circles. But we're taking as our starting point, sorry, the definition that we have here, right? And I want us to focus that the benefit, right, or that we're trying to mimic the strategies used by nature, right, to respond to challenges in a harmonious way, right? That we're trying to design human communities, human responses to the challenges we face that situates us within a greater balance and harmony within the natural world. That's what biomimicry is really about. Um, I don't know if this rings a bell, but several months ago I gave a class on permaculture. Actually, I think I've done two classes now on permaculture. And if you participate in those classes, you might or you might hear some similarities between the ideas of biomimicry and the ideas of permaculture. And it's because permaculture, grows from this idea of biomimicry. So permaculture, just to remind us, is a design process that is founded in trying to replicate or imitate natural patterns that are found in ecosystems, because these solutions the natural solutions that we see in the natural world have emerged through evolution over thousands and in sometimes millions of years and have proven to be effective. As a result, the implementation of permaculture design will vary widely depending on the region of the earth it's located in. So when we talk about permaculture design, we're talking about how can we design human communities? How can we design human agricultural systems? How can we design architecture, human homes and the businesses that we live in? How can we design a human culture that tries to mimic the wisdom of the natural world? And the wisdom, the idea that that this is wise is that the industrial way of life, right? This idea of that human beings can using the words of like Francis Bacon and other kind of Renaissance era thinkers that we need to take nature and subdue her and beat her. A lot of times there's these very violent languages that grew out of this Renaissance way of thinking, that nature has to yield her secrets to us, and that we are going to exploit that wisdom for our own kind of benefit. That's one way of understanding biomimicry. But permaculture says no. There's this idea that the natural world and all of its beauty, its functionality, have grown out of millions of years of slow and patient evolution, right? If you look outside your window and you look at the trees and the animals and the ecosystems, all of these are in your place, right? And obviously, what permaculture says is that every place is different, right? There's a huge difference in what natural solutions are going to work in a desert environment versus a mountain environment versus an Arctic environment. But the idea is that these processes grew and adapted to the specific context of a place, right? And in science, today is beginning to understand and appreciate that, right? Because science is about observing and trial and error. And many scientific the scientific process, the scientific method is kind of about this trial and error process. And scientists who have a profound respect for the natural world understand that when you try to mimic the natural world, you're taking advantage of millions of years of trial and error, millions of years of the scientific method. Whereas, most scientists in laboratories today are building off of research that might be a year old or processes that might be a couple years old, whereas the natural world has a scientific method that spans back millions of years, right? So there's a lot of wisdom in trying to learn from what has worked, what is working, what nature has selected for in specific places, right? Permaculture's design principles are essentially based on the scale, pace, and pattern of lessons that can be learned from observing the natural world. And I want us to really focus on this importance of scale, pace, and pattern. Scale refers to how large, what is the correct size for a certain thing, right? Some trees, have evolved in a forest ecosystem to grow to a certain height. Other trees have adapted to grow in the subcanopy layer to be able to photosynthesize light with a lot less direct light. Others, on the forest floor can survive with in almost 100% shade. The pace refers to how fast, and the patterns are obviously how things are organized in the natural world. In permaculture, this design process of how we design agriculture, food systems, energy systems, architectural systems, human cultures, is about trying to look at the natural world, observe that patiently, and understand that there are scale, pace, and pattern examples that we can use for designing human communities. So biomimicry and permaculture converge and have a lot in common. I wanted to really, make that kind of explicit from the outset. So let's look at some historical examples of how past communities have used biomimicry. This is a picture of an Arctic hare. It's a type of a rabbit, but this isn't a rabbit that I will find where the Arctic hare is native to the tundra areas of the northern latitudes of our planet. And one thing that you'll see, I think, of the Arctic hare is one that it's white. That's obviously an adaptive trait to help it blend into the snowy environment where it lives to protect itself from predators. But then also you notice these enormous back feet, right? Several times larger than most other types of rabbit species around the world. And the reason is that the snowshoe hare, this type of rabbit from the Arctic regions, has to move across snow, right? And with very small feet, what would happen is that the snowshoe hare would sink into the snow, and it would be hard for it to move. So over millions of years of evolution and adaptation, they develop these very, very large hind legs, which allow them to move on top of the snowdrift so that they don't sink in. So snowshoes, I don't know if you all know snowshoes, but for people who live in snowy areas, you can go to a sports store and buy these essentially these large shoes that have a very, very large surface area, and it allows you to go out during a snowstorm and walk across the snow without sinking up to your knees. So snowshoes are a development based on the observation that snowshoe hares, with their large, oversized feet, were better able to stay on top of the snow than animals with smaller feet. The traditional snowshoe, as we know it, is an invention of the North American indigenous peoples. These people who lived in very snowy, cold climates and was especially common in northern tribes where travel through deep snow was a regular occurrence. So if you lived as an indigenous person in northern Michigan, where my ancestors were from, and you had to go out to hunt or to check your traps in the middle of a snowstorm. If you didn't have snowshoes, you would end up, chest deep in snow. And so these indigenous communities, by observing the snowshoe hare, were able to develop a very innovative technology, which are snowshoes, which allowed them to move easily and quickly throughout their environment. So this is one historical example, and there are dozens and hundreds of examples of how indigenous communities developed technologies, tools, different kind of cultural patterns based on what they observed in the natural world. In essentially the lifestyles, the cultures that indigenous populations developed were almost always about how they applied the observations of the natural world to their own cultural manifestations. In the West, in Western history, famous thinkers such as Leonardo da Vinci were also extremely involved in this biomimetic process, this process of observing the natural world and trying to design inventions and innovations and science based off what they observed. Da Vinci is known obviously as an artist, but he was also an inventor, one of the most forward-thinking inventors throughout history. He maintained that nothing mankind could ever create would compete with the elegance, beauty, economy, or functionality of any of Mother Nature's inventions. And as such, he was also one of the great innovators in biomimicry. This is a quote from his journals, his diaries, that are a great read if you ever find yourself with time reading Leonardo da Vinci's kind of journals or his personal thoughts. But he said in his journals that human subtlety will never devise an invention more beautiful, more simple, or more direct than does nature. Because in her inventions, in nature's inventions, nothing is lacking and nothing is superfluous, right? Leonardo da Vinci was extremely interested in the phenomenon of flight. How things fly. And if you look through his journals, he has all of these magnificent kind of sketches of kind of a primordial type of airplane, and then also a primordial type of helicopter. And he, observed how dragonflies and other insects flew, and through this kind of these proportions, these mathematical kind of ratios, he was able to devise. He was never able to create it, but if you look back at his drawings and his proportions, he essentially invented, sorry, the helicopter, dozens of centuries before, or 500 years before it came into being, and he did this through understanding that the natural world offers an enormous wealth of knowledge if we have the patience and the ability to observe it. So Da Vinci is also considered one of the primary thinkers in biomimicry. Um, so that's what biomimicry is. It's about observing the natural world, understanding the wisdom that comes from millions of years of biological and evolutionary adaptation, and trying to understand how we can fit our lives into it. However, like I mentioned, today there is kind of another branch of biomimicry, which I think we should call superficial biomimicry. So this idea that all we have to do is again kind of using this language of Francis Bacon, one of the famous Renaissance or Enlightenment thinkers, saying that we need to subdue nature, we need to chain her, and extract from her secrets, so that human beings can then control the natural world. That's kind of one starting point of biomimicry. Um, and it's one that, like I said, lots of technology corporations, lots of big businesses are latching onto, because I think they understand that there is a knowledge in the natural world, and we have to, and it's this idea we have to try to capture that knowledge for our own good. So that's what I mean by superficial biomimicry, whereas deep biomimicry is going back to these ideas of Leonardo da Vinci, of really wise indigenous groups that say the natural world has evolved uh, a sense of balance and equilibrium, a sense of true sustainability that teaches us how to live in right relationship with our community, with the geography, the territory, the environment where we live, and to kind of show this dichotomy between superficial and deep biomimicry. These are two definitions that I drew from the internet. The first one is actually from a biomedical engineering company, one of the leading biomedical engineering companies in the world, and they have a whole page on their website dedicated to the importance of biomimicry, and they say that biomedics or biomimicry is the emulation or the mimicry of the models, systems, and elements of nature. And here's the kicker: for the purpose of solving complex human problems. So, from a very superficial standpoint, biomimicry, the only use of that is to solve the problems that we have today, right? So, a lot of businesses are saying, okay, we know that we're facing an enormous a variety of ecological and environmental and human health problems that have grown out of the industrial age. We can try and mimic nature to solve that problem in nothing more, right? Or we want to try and mimic certain natural processes so that our company can become more competitive in the global marketplace, in global capitalism. That's one very, like I said, superficial or limited definition of biomimicry. Another definition, and this is from the Bio-Mimicry Institute, which takes more of a depth or profound kind of look at what biomimicry really entails. And it says biomimicry is about learning from and then emulating nature's forms, processes, and ecosystems to create more sustainable designs. So there's a huge difference. On a superficial level, it's simply about using the wisdom of nature to solve complex human problems. And on a more depth level, it's about doing the same thing, observing and replicating nature, but in the purpose, for the deeper purpose of creating more sustainable designs. This is an example here. So many navies, I think the US Navy back about 75, 80 years ago, they were trying to design torpedoes for their submarines. This was during World War I or World War II, I forget which one, sorry. But they were trying to think, how can we create, better torpedoes so that our submarines can outcompete the Germans, in international waters. And one innovator said, look how fast penguins are able to propel themselves through the water. And say they took this design criteria of how a penguin can propel itself through the water, and based on the penguin kind of adaptation, they created a new design of torpedo. We can argue whether creating weapons of war, things that are going to be more efficient, killing machines, more efficient at destroying the enemy if that is a smart or a wise use of biomimicry. But that's certainly one example that has been used. Um, like I mentioned, in the terms of superficial biomimicry, there's recently been an enormous investment, millions and billions of dollars being invested by militaries and corporations into biomimicry research. The Israeli Army, the Israeli Armed Forces, recently designed a drone butterfly as a surveillance type of mechanism. Essentially, they looked at how butterflies were able to fly while maintaining a very small and a very light kind of composition, and off of this kind of the mechanics of butterfly flight, they were able to create these very tiny drones with these mini cameras that are able to fly into small spaces. They don't only use it for military purposes, but it's also been shown that they use these what are known as butterfly drones to spy on their own population for surveillance purposes and things like that. So that's one example. There was actually in 2010 there was a pretty influential article in Newsweek, and the title of that article was "Biomimicry Turns Nature into a Factory." And again, this is kind of building off of this Enlightenment age thinkers, Francis Bacon, Rene Descartes, who had this idea that we need to corner nature, we need to tie her down and beat her and extract her knowledge and her wisdom for our own purposes, for human control, for humans to be able to design and implement a world of our own making. Um, and that's still the purpose today. Here's from that Newsweek article back in 2010. It says the emerging field of biomimicry taps the manufacturing secrets of spiders, abalone shells, lotus plants, et cetera, et cetera, et cetera. And I think that's fascinating. One way, if we look at the natural world as having manufacturing secrets, versus looking at the natural world as this enormous diversity of life, of processes that are well adapted to certain places, right? There's a difference in mindset, an epistemological difference of how we understand the world as something that can yield us manufacturing secrets or something that can teach us about how to live in right relationship with the natural world. So that's kind of the essence of the difference between superficial and deep biomimicry. That Newsweek article also talked about how companies were trying to create bionic ants as future factory workers, right? So obviously, when you look at ants in an anthill, they have this enormous coordination, and everyone does their own participation. And it's about how can we adapt this kind of servile attitude to the factory, to the manufacturing workplace. Real quick, kind of to end this difference between superficial and deep biomimicry, hundreds of millions of years of trial and error have perfected nature's designs, right? Mainstream scientists and innovators today understand this and are thus attempting to extract those design advantages for modern innovation, new technologies, market competition, etc. One example of that is recently some of the godfather of AI, Geoffrey Hinton, who used to work for Google. He said that in the beginning of research into how artificial intelligence systems were created, they were innovated into being through neuroscientists having begun to map the enormously complex neural networks of the human brain, right? So once we understood certain aspects of how the brain works, AI researchers said we can do this, and you can use neural networks to design how artificial intelligence algorithms might work. So that's kind of how modernity in this modern day techno-industrial civilization in which we live are using biomimicry. However, this superficial sort of biomimicry fails to grasp the other essential aspect of nature's wisdom, which is this: that every innovation and every adaptation produced through evolution fits perfectly into the balance and equilibrium of the sustaining ecosystem. If it doesn't contribute to that balance, then that that characteristic, that trait, that innovation will become evolutionary maladaptive and will be selected against, right? If something in the natural world does not fit into the larger pattern of its ecosystem, it will become extinct. That's a law of biology, a law of evolution, a law of the natural systems where we live. Modern science and technology, however, have completely ignored and failed to see the foundational importance of having innovation and technologies fit into the sustaining balance of the overarching system of which it is a part. Butterfly drones, penguin-inspired torpedoes, AI systems that increase our ability to extract from the natural world. These might take their design criteria from nature in a very limited sense, but they are not learning about how the butterfly adapted to fit into a natural ecosystem, or how a penguin fits into a natural ecosystem, or how the human brain evolved to inspire wonder, right? When we simply extract the manufacturing secrets of the natural world, we're forgetting the most important aspect of biomimicry, which is essentially that if a organism or a thing does not learn to live in equilibrium with that which surrounds it, it will become maladaptive and it will grow extinct, right? And I think we've forgotten that foundational element, right? Sarah El Sayed is a biomimicry researcher with the Biomimicry Institute, and she says that biomimicry is the conscious emulation of nature's genius, right? Nature has evolved the most adaptable strategies. And as human designers, we can gain inspiration from these strategies to create systems that are sustainable and even regenerative. To be true biomimics, we also need to learn how to reconnect to nature, to be a part of it, and have an ethos that guides us to be well adapted to this earth. Right? So biomimicry isn't just about manufacturing secrets. It's not just about trying to create innovative products that are going to allow us to conquer more of the natural world, to impose our order, our design criteria for a human system, right? We have biomimicry is about observing the natural world, learning from it, and then understanding that we have to develop an attitude that will allow human cultures to become adaptive in the evolutionary sense, right? Through understanding that we need to adapt ourselves to the natural world, to the ecosystems where we live. Wes Jackson, who's an author of a book that talks about this called Consulting the Genius of This Place, he says, only by consulting the genius of our own places, instead of imposing our will upon them, can we, talking about human beings, carbon-hungry creatures, avoid the fate of the petri dish. And what he is mentioning about that is petri dish is an example of a bacteria that if you put it in a petri dish and you start to feed it food, it will continue to grow and multiply until it consumes all of that food, and then once its source of nutrition is gone, it dies, right? It extinguishes, it collapses, right? So if we're going to avoid the example of the bacteria in the petri dish, we need to learn how to learn from nature in the sense of adapting limits, adapting right livelihoods, and adapting adaptive cultural and personal behavioral practices that allow us to fit into the places where we live. Um, the Biomimicry Institute outlines three essential elements of deep biomimicry. Again, deep biomimicry is about really trying to learn from the natural world in order for human societies to fit in to our places. And so the three elements of that is one, emulation, which is kind of where mimicry comes from, which is the attentive practice of learning from nature's forms and processes to guide human innovation and to create more regenerative design solutions. And this idea of regeneration kind of stems from the idea that over the past 300 years of human civilization, we have degenerated the world in which we live. This focus on on again trying to take the natural world and learn her secrets and subdue her so that human beings can create a world to our own liking. The result of that are all of the social and ecological and environmental and human health crises that are compounding into what's known as the meta crisis or the poly crisis, right? We are at a moment in history where we need to understand that the biomimicry, this emulation of nature, isn't just about fitting into the natural world, but how we can actively participate in regenerating the natural world upon which we depend. The second essential element of deep biomimicry is an ethical framework, right? We need to have a commitment to apply the lessons learned from life systems in a manner that creates conditions conducive to life, and a recognition that we have a responsibility to conserve and protect that which we are learning from, right? If we are learning from nature to create, more advanced military weapons or new surveillance, devices, or artificial intelligence systems that are about replacing the human brain and replacing human labor, I don't think that we can say that we are responsibly that there's an ethical framework guiding that innovation and that biomimicry innovation. We have to understand that true biomimicry is about learning that we have a responsibility to participate in the conservation and regeneration of the natural world. And lastly, reconnection, an acknowledgement that humans and our activities are not separate from nature, but are a part of the natural world, affecting and affected by all other organisms within Earth's interconnected systems. As a practice, reconnecting with nature encourages us to observe and spend time in nature to better understand how life works so that we may more effectively appreciate and emulate biological strategies in our designs. If we go back to the idea of a butterfly drone, right? You can take a butterfly from the natural world, take it into a laboratory, do some tests, see how it operates, what are the mechanics of butterfly flight, so you can extract it from its ecosystem, from all of its other connections with the natural world, and yes, try and learn some things about how to develop tiny drones. Or you can go into a forest, into a prairie, observe how a butterfly and how its flight patterns interact with flowers, with plants, how it plays this very, very important role in being a pollinator species, about how it is a connector between the plant and the animal worlds. And that will teach us something much deeper than simply how to emulate its flight to create a drone for surveillance, right? It can teach us about how to adapt, how to help pollinate, how to create a thriving ecosystem, right? So it's about reconnecting with the natural world in order for biomimicry to really gain a depth, right? Um, the Biomimicry Institute also, besides its three kind of foundational elements, it also talks about basic principles of biomimicry. And real quick, this says, nature runs on sunlight, right? And I think that's important. And it only uses the energy it needs, right? So biomimicry needs to understand that there is a limitation to the amount and the type of energy that we have available, right? If we're using nature's designs to create torpedoes that are going to run, on these nuclear powered submarines, well, we're kind of avoiding these first two principles, right? No, we need to understand that the natural world runs on this constant, uh, powerful source of renewable energy, which is the sun, right? And it only uses the energy it needs. It's not about wastefulness. It's not about this energy gluttonry of having an enormous amount of energy always available to us. Another one is nature fits form to function, right? If there is a function that's needed, the natural world will develop a form through slow evolutionary adaptive practices. Nature recycles everything. There is no waste, right? If we're going to use biomimicry, we need to understand that the waste products from our manufacturing processes, from our innovation, from our technologies, have to feed into some other system so that it is not simply wasted. Nature rewards cooperation over competition. Nature banks on diversity. If we're trying to extract from biomimicry this kind of lack of diversity, one type of system or design that can be implemented around the world, then we're failing. We need to understand that every biomimicry, that every innovation in the natural world responds specifically to the particular conditions and contexts of a specific place. Nature demands local expertise. It curbs excesses from within and it taps the power of limits. Those last two, I think, are very, very important, right? If there is something in the natural world that is excessive, that is going beyond the natural equilibrium, well, the natural world will evolve to get rid of that thing, right? If there's something that is promoting cancerous growth, that is taking more than its fair share, that is not coexisting within the laws of equilibrium, the natural world will ensure that that thing collapses, that it extinguishes, right? And one of the reasons it does that is because the natural world understands that limitations and boundaries and restraint are a fundamental aspect of what it means to be alive, right? There is no thing, no live thing that can live without limits, right? And I want to kind of to end, I want to talk about the importance of that, the importance of embracing limits to spur real creativity and innovation. One of the reasons that is because when we live within limits, within boundaries, within restraints, well, that spurs innovation, right? When you have to say, one example that I always like to give is several years ago, me and my family put solar panels on our house. We went off grid, right? And before we did that, we were connected to to our national energy grid. And yeah, we talked about how to turn off the lights and how to try and save energy, but really we were never challenged to do that because there was no limitation to the energy. We always had endless amounts of energy. Anytime we wanted to turn on a switch or turn on an appliance, we could do that. When we went off grid, however, it quickly became very obvious to us that the batteries that the sunlight that was shining on our roof, the batteries that were storing the energy that we used had real limitations, right? And so that spurred innovation about how we could really save energy, right? And so we developed all of these strategies as a family to not turn on the lights during the day. We instead of preserving our food in a refrigerator, we built a kind of like a little cave where we store our food using the natural cold processes of the natural world. And so, because of the limitations of energy available to us through the solar system that we have on our roof, we're able to come up with all of these innovative ideas about how to reduce the amount of energy we use. Another example is farming. The process of growing food naturally extracts nutrients from the soil. If we don't replace those nutrients, yields will diminish, the soil quality will diminish. So there's kind of two responses to that. One, we can innovate chemical fertilizers and hope that chemical fertilizers will continue to provide us with an enormous amount of yield, or we can develop farming practices that mimic the natural fertility cycles of forest and prairie. If we do that, we understand that fertility requires certain limitations about how we grow certain things, right? It's about replenishing, about regenerating the soils. That's about learning to operate within the natural limit, the natural boundary of the soil food web, right? Understanding the mechanics in the biology of how soil maintains fertility and then adapting our farming systems to replicate that. That's about learning the natural limitations of how soil fertility maintains itself, right? Learning to create abundance within boundaries and limitations is the real challenge of effective biomimicry. And lastly, our technologies, the technologies we use, play an enormous role in this, right? I think there's two different ideas of technologies. The instrumental vision of technology is this idea that technology is an end to achieve, or is a tool, sorry, to achieve only human ends, specifically that of building up or arranging a human designed and controlled world, right? So our niche, ecological niche as a species is to use technology, but we can do that in by mimicking the natural world to implement a world of our own design, only that only responds to human needs, to human wants, to human desires, to human economies. Or we can use convivial tools, which is the term that Ivan Illich used. And he said that convivial tools are those which give each person in each community who uses them the greatest opportunity to enrich the environment with the fruits of his or her vision in a spirit of balance and equilibrium, right? So, this idea of using technologies to create a thriving and abundant world within the natural limitations of place. I think that's kind of the challenge of where biomimicry sits today. How can we use technology, ingenuity, innovation in a way that allows human communities to benefit while also maintaining the ecological resilience of place and also maintaining the ability to regenerate that which we've already destroyed. I'm going to go ahead and end my presentation right now. Make this bigger. And we have about 10 minutes left for questions. So I'd ask Dr. Cambito if he could help share or help moderate any questions that our students might have. Thank you very much.
Thank you, Professor Tobias Robertus. Really appreciate uh, for coming with this fresh and interesting idea on how we learn from our surroundings, our natural environment. Really, it is very attractive. Appreciate for your time and for your commitment. Now it's a time for anyone to ask the questions concerning the topic of presentation. Hi, it is your time to bring the questions or any suggestions about the topic. How you see the topic, it is very interesting. Biomimicry. I love it. There is one question, I think, the chat section. If you see,
Yeah, from CC Jules, it says, science without conscientious threat, human being. We face most of these cases in lifetime, but how this happens, when technological innovation should be inspired by nature. Uh-huh. I think what I understand from that is this idea that science without a conscience it can be a threat, and I agree 100%. It's again, it kind of goes back. I've repeated this several times, but this kind of enlightenment idea that the natural world can be exploited for only human ends, right? And I think that we see that. So, I mean, just taking the one example of energy, right? We learned how to, or we discovered the energy sources of coal and oil and natural gas, right? And we discovered how we could burn those to give our modern day civilization this enormous amount of energy surplus. But when we did that, we didn't think about all of the negative aspects of obviously climate change and greenhouse gas emissions and things like that. Again, going back to the Biomimicry Institute, if we look at how the natural world uses energy, it focuses on renewable sources, so sunlight, right? And it also understands that there needs to be limits to how much energy we can use. Any animal, any plant, any live system only has access to a certain amount of energy, right? How can we do that as well? How can we kind of create this space where we can innovate in energies and things like that, but we need to innovate in energy, understanding that there is a right limit, there is a scale, right? There's a correct scale for how much energy human beings and human societies and human civilizations should have at their disposal.